Good afternoon and greetings to respected teachers, esteemed judges, and my fellow students and audience. Today, our group will present our innovative project, Smart Cities Breeding Routes. And this project was developed as a part of our critical thinking and science of creativity courses, and is a new type of road designed not only for transportation, but also to actively clean the air we breathe. And we will walk you through the point that we identified, our solution, the design, the feasibility, and the overall impact of this innovation. This is the result of our entire course journey from understanding how to think critically and to be creative and being future innovators. And we studied various Harvard case studies and held intensive brainstorming session to present to you our innovative project. So our team consists of 6 members who are Ko Liang, Devin, Brian, Castel, Jonathan, and Alex, each member contributing to a different aspect of the projects. Here, you can see how we divided responsibilities. Ko Liang served as a team leader, established the project's objectives, develop the adaptive hybrid framework, and manage implementation from R&D to commercialization. Devin was the deputy leader, formulated the project vision and strategy, conducted market and competitive analysis, and developed the B2G or B2B business and revenue model. Brian prepared user guidelines, compiled activity plans and risk mitigation strategies, and finalize acknowledgement, lessons learned, and the project conclusions. Castel designed the photocatalytic mechanism, a pollutant breakdown process, and multi-layer system, and planned the project lifecycle and prototyping phases. Alex defined key product features, conducted technical and financial feasibility studies, and performed SWOT and pastel analysis to assess market viability. And the last, Jonathan supported documentation by compiling report page screenshots and preparing case study title slides. And together, we combine our strengths to deliver this project. This division of tasks ensure efficiency and allowed us to focus on our strengths while supporting each other throughout the process. This is the video about our innovative product.
Even a small forest can remove the emissions of thousands of cars every day. But we don't have room for forests where air pollution occurs. What if our city streets could act more like a forest and remove pollution? With help from the sun, titanium dioxide treated roads from pavement technology now can literally eat smog. When TiO2 is energized by light, millions of electrons create an energy field atop the road. When cars travel along a TiO2 treated road, pollutants are captured and oxidized, instantly removing the airborne threat. Pollution capture is important technology, and scientists agree. Titanium dioxide is a proven way to remove toxic vehicle emissions like nitrous oxides and other pollutants harmful to humans. A single mile of titanium dioxide treated roads can stop as much pollution as 20 acres of trees. Now our city streets really can act like forests. Real science, real results. Pavement technology.
And this is the expert interview.
Hello everyone, this is Brian Valentino from Group 3. Today I have the privilege of speaking with Mr. Gobin, who is an engineering alumni of Nanjing Tech University, currently studying in Tsinghua University of Beijing, to get his perspective on our project. So, Mr. Gobin, the first question I want to ask is, in your opinion, do you think this project is actually feasible in the real world?
Yes, this project is realistic and technically sound. The core technology has already proven effective in real-world tests, such as a tunnel trail in Seoul that reduced air pollution by approximately 18%. The primary challenges are no longer scientific, but rather economic and logistical. To scaling it up, production, and lowering the cost. By utilizing the cost-effective materials derived from the waste streams, and by building partnership with the cities, government, and the manufacturers, this innovation can transition from pilot project to standard urban infrastructure.
Okay, that's a very clear perspective on the practical challenges that actually leads perfectly into our next question. Looking at our analysis, what unintended consequences do you think we should be investigating more deeply?
Several important risks warrant closer examinations. Environmentally, the longer term impact of the runoff by carrying dissolved nitrates byproducts, so it must be assessed to ensure it does not harm local waterways and ecosystems. Technically, the material durability under decades of traffic, weathering, and maintenance need more real-world validations. Socially, without careful planning, deployment could favor affluent or showcase area, worsening environmental inequity. A fair implementation strategy should prioritize communities most affected by pollution. Additionally, independent and transparent verification of performance data is essential to overcome public skepticism and avoid perception of the greenwashing.
Yeah, those are some very critical points. I think it's definitely clear that managing those risks is very important. So, shifting to a broader vision, if we can navigate those challenges and if the project does succeed, what impact do you think it could have on our world?
Hmm, So, if it is successfully implemented, the breathing roads could transform urban living. The most immediate benefit would be clearer air in pollution hotspots, such as tunnels, school zones, and congested streets. That's leading to tangible public health improvement. On the large scale, it would redefine urban infrastructures, turning passive surface into active environmental assets and accelerating the transition towards smart, sustainable cities. This model could be adapted globally, offering a scalable solution to urban air pollution. In economically way, it will create new green jobs, like in material manufacturing, installation of the roads, and also the smart monitoring and positioning cities at the forefront of climate resilience development.
All right, that's all my questions. Thank you, Mr. Gobin, for your valuable insights. They'll certainly help us refine our project and think more critically about its real world application. We really appreciate you taking your time to share with us today.
For the next part, we will show you the content of our presentation. As you can see, guys, these are the contents of our presentations, which will be covered today. These are the contents of our presentations, and we will begin by introducing our team and the problem we aim to solve. Then we'll present our innovative solutions, along with its design, and then a technical feasibility, and we will analyze market demand and share survey results. Finally, we walk through our financial plan, SWOT and PESTEL analysis, installation procedure, product life cycle, and conclude with our learning outcomes and future opportunities. As you can see, this is our executive summary. Smart cities breeding roads turns roads into air cleaning surfaces using a titanium dioxide photocatalytic coating that breaks down pollutants like nitrogen oxides, sulfur oxides, and VOCs under light. With IoT monitoring, they provide a real-time air quality data, offering a scalable solution to improve urban air quality and sustainability. So, in introduction, urban air pollution is increasing in busy city areas, while most infrastructures remain passive. And for smart cities breeding roads, transform roads into active environmental solutions, reducing pollution and supporting healthier, more sustainable urban living. So for this slide, we can see and outlines the project objective. In these slides, we're focusing on our visions, mission, and core strategic goals to guide the development of smart cities breeding roads toward a cleaner, healthier, and more sustainable urban environments. In our vision is to transform urban surfaces into active air purifiers. By turning roads and structures into self-cleaning infrastructure, we aim to improve public health and support smarter, more sustainable cities. Our mission is to develop and scale viable protocolytic materials that reduce urban air pollution through research, reward testing, and partnerships. And we aim to measurably cut pollutants like nitrogen oxides, sulfur oxides, and VOCs in cities. For our core strategic objective, we focus on 5 key areas. First, innovation by developing next generations, sustainable protocolytic materials. Second, a validation through a real pilot projects to prove performance and reliability. And third, commercialization by scaling production in cost-effective and certified manner. And the last, integration by enabling IoT connectivity with smart city systems. Finally, impact by delivering cleaner air and improve public health and more equitable urban environments. As you can see, this is our market status. The smart city and urban air quality market is rapidly growing, driven by stricter regulations, public health concerns, and technological advances. As research moves from laboratories to real-world deployment, pilot projects have proven that photocatalytic infrastructures can effectively reduce pollutants like nitrogen oxides in challenging urban environments. Recent breakthrough in low cost. Sustainable photocatalysts have improved commercial viability compared to energy-intensive or land-dependent alternatives. Breeding roads offer a unique, a passive, and scalable solution that integrates seamlessly into smart cities ecosystems. And this is the global titanium dioxide market. It's projected to experience a significant growth between 2025 and 2035, with both market value in USD billion and year-over-year growth rate analyzed. Concurrently, the 2023 market is segmented by key applications, led by paints and coatings, followed by plastics, inks, paper, and pulp, cosmetics, and other emerging uses. Together, this analysis outlines the evolving demand drivers and growth trajectory for titanium dioxide across major industries. So today, in our outline for our business model and the key pain points it solves, we begin by identifying the significant pain points in the market that we have addressed. We will then walk through our business model, detailing how we create value and conclude with an overview of our primary revenue streams. This framework connects the problem, the solutions, and the financial sustainability of our venture. For pain point areas, our cities face severe air pollution, especially at congested roads, intersections, and tunnels, posing serious health risks. Traditional infrastructure warns heat and runoff issues, while existing air purifiers are costly, energy-intensive, and harder to scale. For our solutions turns everyday urban surfaces into active, a self-cleaning system that efficiently and stably purify the air. For our business model, our hybrid business model target both public and private sectors, and we partnered with a municipalities, it's called B2G, for project integration and green funding, a licensed technology to construction firms, it's called B2B, and collaborate with engineering companies for large-scale adoptions. Additionally, our IoT-enabled DaaS platform provides real-time air quality data, ESG reporting, and predictive maintenance, generating recurring revenue while delivering environmental and health benefits. For the revenue streams, revenue comes from 5 main streams. First is selling premium photovoltaic materials. Second, offering special application services. The third is providing subscription-based performance monitoring. Fourth is certification, licensing technology for royalties. And 5 is consulting on feasibility project design for breathing loss implementations. And next, Alex will explain another part of the presentations.
Briefing Rose is designed to be efficient, sustainable, and easy to integrate into cities. First, it has a self-cleaning and low-maintenance surface. Thanks to the photocatalytic reaction, it breaks down oils, dirt, soot, and organic waste that usually accumulate on roads and walls. This means cities need less power washing and fewer chemicals, which save both money and water. Second, the system is energy passive. It doesn't need electricity from the grid. In open areas, it works with natural sunlight, and in places like tunnels, it only requires low energy UV or LED lighting. As a result, there are almost zero operational cost and a very low carbon footprint compared to the traditional air filtration systems. Another important feature is rain-assisted regeneration. Pollutants like nitrogen oxides are transformed into harmless water-soluble nitrates, which are naturally washed away by rain. This allows the system to continuously regenerate itself without losing efficiency. Briefing Rose is also very flexible. It can be integrated into new roads and buildings, but it can also be applied as a coating on existing infrastructures. This makes adoption much faster and cheaper for cities. Finally, it is a smart city ready. Sensors can measure air quality in real time and provide data for monitoring, ESG reporting, and long-term urban planning. From a technical point of view, the solution is already proven. A real-life test in a tunnel in Seoul showed around 80% reduction in nitrogen oxide levels in just 24 hours. This is very important because tunnels are one of the most difficult environments with a heavy traffic and no sunlight. Recent advances in material science also improve durability, meaning the photocatalyst remains effective despite traffic, weather, and abrasion. Financially, the initial cost is higher than traditional material, but the total cost of ownership is lower. This is due to lower maintenance costs, no energy consumption, avoided air filtration systems, and long-term public health savings. New production methods using recycled waste also significantly reduce material costs. From a market perspective, the context is very favorable. Politically and socially, air quality regulations are becoming stricter, and citizens are demanding concrete solutions. Economically, cities can save money in the long term while improving public health and urban attractiveness. Technologically, the solution fits perfectly into smart city strategies. Environmentally, it directly reduces pollution at the source with minimal negative impact. Of course, there are risks such as a higher upfront cost and skepticism from conservative construction industries. However, the opportunities clearly outweigh the threats. To evaluate our project, we carried out a SWOT analysis. First, the strengths. So our solution uses existing infrastructures like roads and tunnels. So no extra space is needed. It works in a passive and sustainable way with low maintenance thanks to its self-cleaning properties. The technology is also proven, as we can see in Seoul, where 80% of nitrogen oxides are reduced. So now the weaknesses. The main limitation is the higher initial cost. Performance also depends on conditions such as light exposure and long-term durability data is still limited. Then the opportunities. Smart cities are growing fast and cities are looking for environmental solutions. Our technology also targets non-exhaust pollution, which fits well with electrification, and it can be expanded to other uses like building facades. Finally, the threats. There is competition from other green technologies. Possible skepticism about greenwashing and infrastructure budget can vary. Overall, the project has very strong potential, but long-term performance and cost reduction are key. Castel will present the next part.
Thank you, Alex. Next, I'll briefly explain the installation process, how the technology works, the pre-launch analysis, how we address its limitations, and finally, the project lifecycle. First, for product installation and prototyping, we use a phased approach. The material is first optimized in laboratories, followed by controlled testing under simulated road and tunnel conditions. And after that, pilot installations are carried out in selected urban locations. For new constructions, the photocatalytic material is mixed directly into concrete or asphalt. For existing infrastructure, a spray-on coating is applied after surface preparation, allowing easy upgrades with minimal disruption. Moving on to the technical mechanism, the system works through photocatalysis. So when sunlight or UV or LED light hits the titanium dioxide in the road surface, it triggers a chemical reaction. This reaction breaks down harmful pollutants such as nitrogen oxides and VOCs into harmless water-soluble salts. Rainwater naturally washes this away, allowing the surface to regenerate and function continuously with low energy use. Before the launch, we conduct pre-launch surveys with key stakeholders such as key planners, engineers, and local communities. The surveys help us understand cost concerns, acceptance levels, and identify high-impact deployment areas like tunnels and congested roads. This ensures the solution meets real market and public health needs. And to address these advantages, we focus on long-term value rather than just initial costs. Although the upfront cost is higher, savings come from reduced maintenance and improved air quality. Performance variability is managed through optimized materials and supplemental lighting, while durability concerns are addressed through testing, warranties, and pilot data. Finally, the project lifecycle. In the first 2 years, we focus on research and material development. From the second to fourth year, pilot and demonstration projects are conducted. Between years 4 and 6, the project enters early commercialization and scaling. From the 6th to 10th year, the technology is fully integrated into smart city infrastructure. Beyond year 10, we focus on next generation innovations such as visible light catalysts and adaptive road surfaces. Overall, this structured approach ensures breathing roads is reliable, scalable, and sustainable for long-term urban use. Next, I'll pass the time over to Guoliang to continue with the presentation.
Thanks, Castle. Here is our overall design. Our solution transforms ordinary pavement into an active air purifying system through 4 integrated layers. First, the reactive surface layer, a special coating on top that uses sunlight to break down pollution. Beneath it, the structural base layer, durable pavement that makes it sturdy and easy to install. Next, the activation layer. Efficient lights embed in the pavement to keep the cleaning progress going 24/7. And finally, the sensor and data layer houses air quality monitors that track air quality and show the system's performance in real time. In short, it's a durable road that cleans the air around it day and night. Next is our project rationale and the overall objectives. Imagine if our cities could clean the air themselves, not with massive add-on filters, but with the very streets and buildings we walk on every day. The challenge is urgent. Urban air pollution is a persistent crisis, but conventional solutions are too often reactive, centralized, and costly. Our project represents a paradigm shift. Instead of adding cleanup systems, we transform the city's existing fabric by engineering roads and pavements with intelligent photocatalytic materials. We turn passive infrastructures into a fast, decentralized air purification network. Our goals are to prove these materials can reduce harmful pollutants like nitrogen oxides by over 15% under real-world conditions and last for a decade, to make them cost competitive, and to deploy them where they will have the greatest impact on public health and environmental justice. This isn't just a product, it's a new blueprint for self-cleaning and sustainable cities. Next is our delivery of project. We are managing this project with a hybrid framework that balances control with agility. At the macro level, we use a disciplined stage gate process. We advance through clear pace, and at each gate, leadership reviews hard data to make go or no-go decisions, ensuring strategic alignment and risk control. Within each phase, our teams work in agile sprint. This lets us iterate quickly, refining materials or software based on the latest test result. Critically, we integrate real-world pilot data directly into development, ensuring our solution is validated by actual performance. This approach gives us the structure to deliver the flexibility to innovate. Our project methodology uses a hybrid delivery method for disciplined yet flexible execution. We follow a clear stage gate roadmap with 6 phases, from R&D to scaling. Formal reviews at each gate ensures disciplined progress and smart resource allocation. Key development work happens in agile sprints, allowing our teams to rapidly iterate and adapt based on real-time data. Critically, our pilots are co-development partnerships with cities and industry. This collaborative approach builds trust, proof, and accelerates market adoption. In short, structured stages for control, agile cycles for speed, and deep partnerships for impact. Now is the implementation plan. Our project will be managed by one central team to keep everything on track. The work is split into 5 clear teams, each with a specific job. First, the innovation team works on improving the special air cleaning material. Second is the testing team, runs real-world trials with city partners to prove it works. Third is the production team, figures out how to make the material reliable and affordably. Next is the business team, creates partnerships, and builds the market for the product. And the last, the data team. Use smart sensors to track performance and improve the system. By following a flexible plan, these 5 teams will work together to take the project from an idea to a widespread reality. Next, Brian will explain another part of presentations.
So here are the instructions for how to use and implement the product. For city planners and engineers, implementing breathing roads begins with strategic targeting of pollution hotspots, like congested intersections, school zones, and tunnel entrances. The process involves precise specification, integrating photocatalytic materials into new construction plans, or specifying retrofit coatings for existing infrastructure. We also plan for activation, ensuring maximum light exposure or installing UV or LED systems in enclosed spaces. A critical component is our validation protocol, mandating before and after air quality monitoring to prove tangible results and ROI. For contractors, the process emphasizes precision, thorough surface preparation, precise applications using standard or spray techniques, and the crucial activation step, priming the surface with water mist or commissioning integrated lighting. We conclude with a comprehensive handover, linking the physical installation to our digital monitoring platform for ongoing performance tracking. Here is our activity plan. Our project is built on 4 structured phases. Phase 1 is R&D and formulation. Over the first year, our objective is to optimize the material for maximum performance, durability, and cost. The key deliverables here are a finalized material spec sheet, a comprehensive lab performance report, and the first pilot batch of material ready for real-world testing. Phase 2 is pilot and demonstration. In years 2 and 3, we move into the field to validate real-world efficacy and installation methods. The critical deliverables are the controlled environment test report, urban pilot performance data from our initial sites, and a verified full-scale tunnel demonstration report, like the Banpo tunnel study, that provides irrefutable proof of concept. Phase 3 is commercial scale up. This is where we perform a real business. The objectives are to establish a reliable supply chain and secure our first major project. The deliverables marking our success are an operational production line, completion of the first commercial project, and a detailed market entry case study to guide future experience and expansion. Finally, Phase 4 covers all supporting activities running in parallel. The objective is to build market credibility and ensure long-term viability. The deliverables are foundational, a draft industry performance standard, and a public-facing performance dashboard for transparency, as well as a partner network framework to grow our ecosystem. Here is our risk assessment strategy. First, for performance risk, we lead with radical transparency. We'll conduct extensive long-term pilot testing and, crucially, publish all data, successes, and shortcomings alike. We'll also back our technology with performance-based warranties, putting our commitment in writing. Second, for cost risk, we innovate at the source. We're doubling down on low-cost catalysts like our breakthrough material derived from wastewater sludge. We'll also pursue economies of scale early and seek green production subsidies to fundamentally change the economics. Third, for adoption risk, we build the ecosystem first. We'll also form alliances with progressive government agencies and top engineering firms. We'll secure endorsements from environmental bodies and develop turnkey project packages to make adoption as simple as possible for our clients. Now we'd like to give a special thanks to institutions like the Korea Institute of Civil Engineering and Building Technology, or KICT for short, whose groundbreaking work on waste-derived photocatalysts and real-world tunnel trials provided the critical proof of concept that moves our idea from theory toward practice. We also extend our gratitude to the broader community of researchers, urban planners, and forward-thinking city leaders worldwide, whose collective work inspires and informs our integrated approach to sustainable urban innovation. First of all, we realize that real-world validation is everything. A high lab efficiency rating does not guarantee a working city street. Success depends on performance under real pollution, variable weather, and constant wear. That's why our strategy is pilot first, and generating irrefutable field data is our single most important task. Second, We also came to understand that cost innovation is as critical as technical performance. The biggest historical barrier hasn't been science, but economics. The groundbreaking work by KICT to create catalysts from wastewater sludge taught us a fundamental lesson. True scalability requires turning cost problems into resource opportunities. And finally, maintenance must be designed in and not added on. Early photocatalytic surfaces failed when byproducts clogged them. The key insight was to engineer the chemistry so that the end products are harmless, water-soluble salts washed away by rain. This creates a self-regenerating system, which is essential for permanent infrastructure. Looking ahead, our future development focuses on four key opportunities. First one is next-generation photocatalysts. The premier goal is developing a highly efficient visible light-activated materials. This would let us deploy in cloudy climates, deeply shaded urban canyons, and even indoors, breaking our dependency on direct UV light. Second is multifunctional smart pavements. We imagine surfaces that do more. Future composites could integrate materials to mitigate urban heat, harvest energy from traffic vibration, or even feature responsive markings for dynamic traffic management. Third is AI and data-driven optimization. The data from IoT sensors is a goldmine. We'll develop machine learning models to predict maintenance needs, dynamically optimize tunnel lighting for energy savings, and model citywide pollution flow to guide future deployments. Lastly, is comprehensive sustainability analysis. We commit to conducting full life cycle assessments, or LCAs, to provide or prove the net ecological benefit of our entire system, from sourcing recycled materials to end-of-life recycling. This transparency is key to validating our true environmental claim. Right. So we've shown that smart cities breathing roads represents more than a technological innovation. It is a paradigm shift. We propose transforming passive infrastructure into an active, intelligent layer of the urban ecosystem, capable of purifying air, reducing maintenance, and enhancing public health. Our analysis confirms the solution is scientifically sound, commercially viable, and socially imperative. While challenges do exist, our detailed roadmap from implementation protocols to long-term research provides a clear and actionable path forward. We're not merely proposing a product. We're inviting collaboration toward a new philosophy for a urban life. To build cities that are not just smart and connected, but truly breathing. Cities that actively sustain and enhance the well-being of every resident and the planet we share.
As a group, we have agreed on a shared understanding of a critical thinking. It means thinking clearly and logically, relying on facts rather than feelings. Our goal in using this approach is to make better decisions and solve problems more effectively. This agreement now gives us a consistent method to apply in our future work. Here is our group first case study. True creativity is the opposite of efficiency. It requires unconventional, often slower methods. This means actively working with people who see the things differently and disagree with you, and having thoughtful arguments about ideas to strengthen them. It means being willing to try new things and to fail, because inaction is a far greater setback. Ultimately, it means following your curiosity rather than sticking only to the rules, because that is how genuine innovation happens.
Case study 2 is based on the weird rules of creativity. This case study teaches us that many things we normally believe about management and work are actually wrong when it comes to creativity. First, it emphasizes thinking clearly. Instead of making decisions based on emotions, habits, or authority, we should question information, use logic, and reduce bias. This helps us make better and more creative decisions. Second, it talks about being creative on purpose. Creativity does not just happen naturally. We need to break routines, work with different people, and be willing to try new ideas, even if they fail. Third, it highlights owning your learning. We should not wait for others to teach us. Instead, we must actively look for new skills, communicate well, and protect our time for meaningful work. Overall, this case study shows that success comes from combining clear thinking, creative habits, and taking responsibility for our own growth. And for case study 3, creativity step by step, it focuses on how creativity can be developed through simple daily actions. First, it encourages us to think hard by looking at facts before making decisions. This helps us avoid guessing and improves problem solving. Next, it tells us to try new things. Doing things differently helps us see problems from new angles and generate fresh ideas. It also emphasizes learning by yourself. So instead of waiting for instructions, we should actively search for answers and improve our skills. Finally, it explains how to work better in a team. We should discuss and challenge ideas, explore strange or unusual thoughts, learn from other fields, and take breaks to refresh our minds. In short, this case study shows that creativity is not a talent. It is a process that anyone can practice step by step.
And for the fourth case study, creativity is a habit that grows through consistent practice. Instead of copying others, learn how they think and use that insight to develop your own ideas. Try new things and changing routines help keep creativity alive. And failure should be seen as a part of the learning process. And by being disciplined, learning from experts, and turning frustration into motivation, you can make a better work. Achieving excellence requires focus on an effort and difficult choices. And for the fifth case study, the creativity starts with thinking carefully before accepting ideas and beliefs. By breaking routines and stepping out of the comfort zones, we open ourselves to a new perspective and fresh ideas. Taking responsibility for our learning allows us to grow independently and continuously. Creativity is not a magic, but a skill developed through practice, efforts, and experiences. To innovate effectively, we must balance that we do today, learn from past habits, and stay open to shaping ideas for the future.
Here is our sixth case study on being a futurist in your own life. This case study taught me that strategic foresight isn't about predicting one fixed future. It's about building it through deliberate small-scale actions today. The core idea was to think big, then plan small. To imagine multiple possible futures, identify what excites you, and then validate those paths with real-world tests before fully committing. This mindset was directly applicable to our Breathing Roads project. We started with a big, visionary idea for sustainable cities, but its success depended on breaking it down into testable phases, research prototyping, and piloting. Just like planning a future career. It showed me that innovation, much like personal development, is built by bridging ambitious vision with agile, evidence-based steps. Here is our seventh case study on Pixar, which revealed that groundbreaking creativity isn't just a solo act. It's a team sport built on psychological safety. The core lesson was that a culture when everyone feels safe to share ideas, where mistakes are seen as essential learning steps, and where diverse viewpoints are actively heard is what turns good ideas into masterpieces. This principle became the bedrock of our group's work on Breathing Roads. We consciously created an environment where every member could critique and build upon each other's contributions without fear. Our plan was structured, yet we remained flexible, adapting to new research and feedback. Ultimately, Pixar's model showed us that the most innovative solutions emerge not from a single genius, but from a collective, continuously learning mind.
So this case study shows us that paying attention to weak signals like small trends or opportunities helps us to make better decisions. We learned that it's better to test things on a small scale, stay flexible when plans change, and focus on what we can control, especially our skills and effort. Overall, the learning outcome is to stay alert, experiment, and the most important, adapt quickly. So slide 51. This case study shows us that innovation comes from thinking for yourself, trying new things and learning by doing. Creativity isn't talent, it's hard work and practice. We learned that to improve, you need to keep what works, stop what doesn't, and keep testing new ideas. Innovation also means exploring different options, then choosing one to try. Finally, good ideas come from open teams with both dreamers and doers, and from paying attention to small change and adapting. Overall, the learning outcome is that innovation is a process of continuous testing, learning, and also adapting.
This is our final report photo. And this is our meeting minutes. Also, next, we will explain what we learned in this course. My approach to problem solving has shifted to focus on evidence, fairness, and flexibility. I test ideas before accepting them. Consider how all parts of a problem connect and affect different people, and learn by trying things in small steps. This carefully way of thinking has led to better solutions, like our Breathing Roads project, which puts this principle into action.
So through this course, I developed stronger critical thinking skills by systematically analyzing problems and evaluating evidence from multiple perspectives. And I learned to question assumptions, assess information credibility, and consider technical, environmental, economic, and social factors in urban infrastructure. This learning helped me understand breeding roads, photocatalytic materials, and their integration with smart city system using IoT and data analytics, and enabling me to propose logical and data-driven solutions.
This course fundamentally rewired my approach to problem solving. I moved from being an information consumer to a creator of solutions. The discipline of weekly case analysis taught me to deconstruct complex issues, separating fact from assumption and evaluating evidence from all angles. That foundation was then tested and transformed in our Breathing Roads project, where I had to apply that same analytical lens, not to critique, but to construct, researching photocatalytic science, bridging it with urban design, and building a logical, persuasive case for a viable innovation. I now carry forward a mindset with not only the critical eye to analyze any framework, but also the creative confidence to use that analysis as a launchpad for building better solutions.
Through the lessons and projects, I learned how to apply structured creative thinking by asking questions, observing patterns, experimenting with ideas, and identifying weak signals that point to future trends. I also developed a stronger appreciation for unconventional ideas, understanding how constraints and collaboration can actually drive innovation rather than limit it. The course strengthened my future-oriented thinking, helping me anticipate change and deal with uncertainty more confidently. In our Breathing Roads project, I combine both critical and creative thinking to propose a solution to urban air pollution, turning theory into practical application. Overall, this course improve my ability to analyze complex problems, challenge assumptions, and create realistic and innovative solutions for real-world challenges.
My personal learning outcomes. So through this course, I developed my critical thinking, teamwork, and self-reflection skills. I learned that creativity is not just abstract, but practical and flexible. One case study, especially, which is with seniors, really pushed me to question the way I think. My final project allowed me to combine the best parts of everything I learned, and team feedback helped me to stay realistic and, of course, on track. Overall, this course taught me how to stay structured, work better in groups, and become a more critical and creative thinker for my future.
This course transformed us into a collaborative team with a shared framework for innovation. Together, we moved from instinct to evidence-based reasoning, applying systems thinking to see urban pollution as a complex web of technology, health, and equity. We embraced structured creativity, not just critiquing ideas, but building them, by bridging fields like material science and urban design in our Breathing Roads project. Strengthened by psychological safety and reflective teamwork, we learned to deconstruct challenges, create solutions, and execute adaptively. Our project is the applied result, proof that collaborative critical thinking leads to responsible, real-world innovation. All right. On behalf of the entire team, thank you for your time and attention today. We've been inspired by the opportunity to present the Breathing Roads project, our vision for cities that don't just exist but actively breathe. If our proposal resonated with you and you believe in the power of critical thinking to build sustainable innovation solutions, we would be deeply honored to earn your support. Please consider voting for Group 3.